Physics students, good afternoon. Mr. Fugit here. In this video today, we're going to be looking at a problem involving circuits and some of the characteristics that go along with describing circuits, things like voltage, current, resistance, and power. Specifically, in this video, we're going to be looking at problem number 8 on homework 14. So our problem statement reads like this. A particular type of automobile storage battery is characterized as 468 ampere hour, 12.5 volts. What total energy can the battery deliver? Okay, so we're given some information here that looks a little bit different than what we're used to seeing. I'm going to write down what we already have. We know that the voltage is 12.5 volts. And we're given this other bit of information, which is 468 ampere hours, which seems a little bit strange. I'm going to write that down. Okay, 468 ampere hours. Okay? Sounds a little bit like a current value because it is given in amps, but there's also a time value. So it's kind of like a current times time, if you will. Okay? Sounds a little bit like that. Now, when looking at the problem, it's asking for how much energy the battery can, I believe, deliver. Okay? So if you remember, energy is equal to, well, power times time. Okay? We can know that simply by remembering power is a rate of energy usage over time. So we can start here. Power is energy over time. Okay? We can move the time value over to get this equation for energy. Okay? Power times time. Okay, so you're probably wondering, why are you telling me this? Okay, this doesn't really seem that relevant to the problem. Well, here's what I want you to understand. The question is asking us for how much energy the battery can deliver. Now, power, if we use one of our equations, remember it's powerful to be able to check your grades. Power is equal to current times the voltage, PIV. So if I substitute that relationship into our energy equation, we get a relationship that looks like this. Energy is equal to power, which is I times V times time. And if you look up at the top, we have I times T, so it would be these two parts, and we also have V. So in looking at our problem statement, we actually already have all the information that we need. We just need to understand how to take what we have and find what we're looking for, right? We can do that by knowing our power equation, knowing that power is the movement of energy or the use of energy over time, and rearranging that equation to solve for energy. So we have the voltage that we need. We have units of current in amps, which is also what we need. But remember, an amp is a coulomb per second. So we're going to need to convert that hour, that time value, to seconds. And that's all we'll do, and then we'll be able to plug in. So here's what I'm going to do. My energy, E, is equal to my current times my time, which is 468 amperes hours. And I'm going to go ahead and convert that to seconds right now. So we know that there are 60 minutes in 1 hour and 60 seconds in 1 minute. Okay? What that's going to do is that's going to get rid of the hours and hours, minutes and minutes. So we'll be in the unit that we want, which is seconds. And then this is really I times T, which is what we have up here. And then we'll multiply by all of this, multiplied by our voltage, 12.5 volts. So we'll go ahead and take a moment to plug that in. 468 times 60 times 60 times 12.5. Now I'm going to get a pretty large number here. So E, our energy, is equal to 2106, 4 zeros, 1, 2, 3, 4. So looks like 21,060,000, and energy is measured in joules, as long as we're in SI units, which we are here. Okay? So this is how we would go through and solve for the amount of energy our battery can deliver based on what we're provided with the current, time, and voltage. Okay? So again, this problem is still utilizing the relationships and equations that we've been learning, and the format and layout just looks a little bit different. Okay? But hopefully this will get you started on solving problem number 8. Okay? Good luck.